Students, sorry for the inconvenience. I hope just I could start again with the problem where I've left. I hope you could see my window. Could you ping me a message saying that screen is visible, something like that? My PPT screen is that visible for you? Post it in chat. It's blur, huh? I hope because of your network, because for past 1 hour you were inside this, right? Is it clearly visible? For few, I hope it would be if they have broadband connection. Thank you, thank you. So I'm running out of time. I'll finish it fast. Okay. So this is a way of converting any number system to any other number system, like from a decimal to binary or octal or hexadecimal. So next problem, what we are going to see is, so far all the conversions and problems involving some Boolean algebra theorems using that, how could you simplify an expression. So far we have seen that. I hope that would be enough, and also go through your DeMorgan's theorem, uh, consensus theorems. So these could be asked in your part A questions. Okay. I have changed the question. Could you see it right now? I have changed it. Could you see that? Could you see the screen changed? Now I am showing the problem for KMap. Is that visible? Yes, I hope. Okay, sorry. In my mobile it was showing something else. Okay, okay. Sorry, ma'am. So now in this, plot the following Boolean expression in KMap and simplify it. This is a question. So what is the function given? F of wxyz is equal to summation m of 0, 1, 2, 4, 5, 6, 8, 9, 12, 13, 14. So as you all know, these are the minterms of the given function f of wxyz. Do make note of it always. If any function is given with a specific variable, then you have to go with the variable. You can't make use of your own variables. Wxyz wxyz. Then okay, that is the first criteria you should remember. If it's a minterm and they are asking you to simplify using KMap அப்படின்னா, then KMap now what kind of, so what are the things you have to remember if I want to start simplifying using KMap now? First, what is a structure? Then what are the kinds of grouping I can go for? So what is a structure? Identify the structure, step 1. So solution is for this problem is step 1. Identify the structure. What is a structure? So to identify, you have, what are the types of structures? You have 2 variable, 4 variable, 5 variable, right? 2, 4, 5 variable. So here, how could I choose out of these 3? And also you have 1 variable. Okay, fine. How could you choose out of these 4 things now? Look at the number of minterms. If it stops by like 1 variable now, that means what? You can have 4 combinations, and 2 variables now, you could have 2 to the power of combinations 4, and 3 variables now, 2 to the power of 3, right? So 8 combinations, and 4 variable now, this is a 4 variable. How many variables? W, X, Y, Z. So 2 to the power of 4, which is nothing but 16 cells has to be there in the structure. Generally speaking, if this is the count of variables, 2 to the power, general expression is what? 2 to the power of n. N speaks about the variables or the bits. Okay, so if it's 2 to the power 1 na, 2 combinations. If it's 1 bit na, either it could be 0 or 1. 2 bits na, it could be 0 0 0 1 1 0 1 1. 3 variable na, starting to 0 0 to 0 1 2 3 4 5 6 and 7. Okay, this is how we say it is a 8 possible combination starting from 0 to 7. What is the total number of values? 8. Okay, so here I need, and they have given 4 variables to 2 to the power 4 now, that means 16 cells in the structure I should have. So I should go for a 4 variable structure. What is a 4 variable structure? This is how it will look. Since I'm making use of my pen tablet, it goes around something like this. Kindly adjust. In your notebooks and in the classroom boards, we would have done it properly. So kindly bear with my presentation in this. So here, as you all know, 0 0 0 1 1 1 1 0, because only one bit change is allowed according to Karna mapping method. That is why we didn't go for 0 1 1 0 1 1. It is 1 1 1 0. So now, what are the cell values? This is the cell value 0. So min terms, these are the min terms contributing for the function. So what are the min terms? 0, 1, 2, 3, nothing was there. Okay. 4, 5, 6, 7 is not there. 8, 9, 10 is not there. 11, no. 12, 13, 14. Okay, so this is how you have to plot this. So these are the cell values. So what is a cell value now? It is a interjunction of your rows and columns. So to this cell value, how am I saying it is a value carrying 0 na? 0 0 0 0 is what? 0. This cell value is what? 0 0 0 1. So what is this is a binary representation. What is the decimal value? If it is 0 0 0 1 na, that is a decimal value 1. If it is like this na, 2. Like this na, 3. So this is how each and every cell value has its decimal value: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so I have plotted using that. So now I'm going to group it. How am I going to group it now? Always there is a hierarchy. So after finding out identifying the structure, so you have to write it, identifying the structure. You have identified as a 4 variable structure. This is first step. See, I have given the theories already, so I'm just saying it out, but you have to write it. Step 2 is what? Plotting the values. We have done that also. And third step is what? Plotting the values. You have to list out all the steps. Okay. Step 3 is what? Grouping the min-term values plotted. So here SOP form na, always you have to plot the values with 1, POS na zeros. Okay, group it. Grouping la, always give importance to the hierarchy. What is a hierarchy now? Always a hierarchy starts from octet. These are the types of grouping. Quad. If octet is not there, you have to go for quad. Then you have to go for pair. Then if nothing was there possible, na, then have it as a single cell. So hierarchy is always, this is first, second, third and fourth. Okay, you should look for a hierarchy while grouping. When it comes for observation, how to group it now? Observe a straight method. Just observe look at the table. Is there any 8 cells together? 8 cells together. What is grouping? How could you group? Adjacent cells only could be grouped. To your, say suppose if you are a cell na, to your left, right, top, bottom. These are the adjacent. So likewise, imagine each cell like that to the top, left, right. And say for this who and all adjacent na, this is adjacent, this is adjacent, this is adjacent, and also this side is adjacent to this side. How now? Folding method. Imagine this as a paper, square paper. If you fold it, all these cells will touch all these 4 cells. All these 4 cells will touch the other side of the top side of the 4 cells. So each and every cell, that is 2 is adjacent to 10, 3 is adjacent to 11, 1 is adjacent to 9, 0 is adjacent to 8. Likewise 0 is also adjacent to 2. Likewise this is also, you can, if you fold it this way, this is adjacent to this. This is adjacent to this. 4 to 6, 12 to 14, 8 to 10. So two ways of observation has to be done while grouping. One, straight look, observe it straight away. Sometimes you get it. Sometimes you have to imagine folding it. Okay, only then you will get the grouping. While doing so, so for example, now you know how you have to observe. Okay. So now coming for the grouping. So what are the ways of grouping? Always I told you octet. 8 cell kuda irka. Adjacent irka. 8 cells are whether adjacent together. Yes, together it is there. To all these 4 cells, all these 4 cells are adjacent and they are together. So I can group a octet. Luckily in this problem you have a octet. If not, what you will do na? If octet is not there, then you have to try grouping a quad. Say, in the given structure, except these three, all other remaining values are grouped. So this is group 1. As soon as you group it, name it as group 1. Okay. Next, what are the remaining minterms left out? 2, 6 and 14. But look at the number of minterms. It has been 3. Wherein octet 8 could be paired together. Quad now 4 cells together. Pair now 2 cells together. Single now 1. Octet means what? 8, quad 4, pair 2 and single now 1 cell. Okay. So here 3 cells are there, which is not possible. But instead I can take these two first. I'm trying to see whether anybody is adjacent to this now. Yes. Why? Because how now? You know, not by a straight observation. Straight observation, I have only a pair, 2 pair. Instead, if I apply folding method, I can have 2, 6 to be grouped with 0, 4. You can borrow minterms from other groups if you could be able to attain a higher hierarchy grouping. Look at the words I'm making use of. You can borrow. I'm borrowing to these two 0 and 4th cells just to get a, or just to achieve a higher order hierarchy. What is a higher order? Next to octet, who is the highest position? Quad, not the pair. So to achieve this, I'm borrowing these two. Next, this cell, 14th cell is left out free. So for that, I can go for, again I can borrow element from, so this is group 2. This is a quad, group 2. Okay. So now, this minterm is left out. For this, so as to group in a higher order hierarchy, who is that? Next to octet, a quad. So as to attain a quad, I can borrow the remaining 3 cells from who and all adjacent to 14, 6, 11, 12 and 4. So I am going to group like this, which is a third group. Okay. You might be asking, shall I do that? Yes. Till then this group is valid. Group 1 is valid because we are making use of the minterms from the group 1. No. Still group 1 needed. Yes, because only few minterms are borrowed. Who and all 0, 4 and 12 are borrowed from group 1. Whereas other minterms are left out. So for that reason I can retain group 1. For that reason I can retain group 1. If all my minterms are, all my cells are grouped by some other groups, then I can remove this group because that will become a redundant group. Okay. Whereas for this problem, it is not like that. So group 1, what is the name of group 1? You have Octet, how will you name it? Look for the common terms. Out of these 4 rows, could you take out anything common? Nothing could be taken common. So leave off the rows. Go for naming, you make use of the variables from the columns. Which could be taken out common? This is y bar, z bar. This is y bar, z. So y bar is common. So I'm going for y bar. If the variables are given in small letters, small letters use pananu. No other go. What is the group 2? Group 2 is the first quad. So which is a common variable? Here W is a common variable. So W bar, and because 0 is there. Next, look at the 2 columns. This column and this column is contributing for the first quad. So which is a common term? 0, 0, 1, 0. Who is found common? This this is common, which is Z bar. So put it as Z bar. Next, what is the next group? Third group is again a quad. Who is contributing now? Ex. Next column, look at the columns, Z bar. Okay, so this is the name of the groups 1, 2 and 3. So I'm just skipping the steps because I don't have space here, but you write it G1 is equal to what, G2 is equal to what, G3 is equal to what, and finally rewrite F is equal to simplified expression. Step 4 is what? Thus the simplified expression is what? Y bar plus W bar Z bar X Z bar. This is a simplified expression, and look at the question. They are asking you to just simplify. They didn't ask you to implement with any of the circuits. So stop with this. This will carry around 6 to 8 marks. Okay, I hope you would have understood. We will move for the next problems. I hope, did you understand? Just put a thumbs up. Just put a thumbs up, so that I can understand you understood. Or at least state understood. Thank you, Akalya. Agnes, Mary, thank you, thank you. Okay. Hey, Mamali, thank you, thank you. So coming out further, kindly you people have your dinner along with this. Uh, Kindly don't skip your dinner. You can watch, because this is going to be a saved video. You can watch later also, or else you can watch and you can have to get. Meanwhile, okay. So coming to this problem, find the following function as the sum of minterms and product of maxterms. So they are again asking you to express a given function in SOP, standard SOP form and standard POS form. That is standard canonical SOP and canonical POS. So what are the steps for SOP form now? F of A, B, C, D is equal to AC bar plus B bar D plus A bar CD plus AB CD. What is canonical? You have to insert. That is, a canonical form of expression will have all the variables in all the minterms. Wherein here B and D is missing. Here A and C. Here D is missing. Wherein here all the literals are present. So this is the only term you are not going to do anything. So here, since SOP internal, you have to multiply with 1. What is that 1 value? SOP form now, B plus B bar. Then C, sorry. Then C bar, D plus D bar. Then A plus A bar. Then B bar, C plus C bar, D plus A bar, B plus B bar, C, D. I'm going fast, I know that. So that my handwriting looks clumsy fully. So now here the simple multiplication, as I told you already, AB. Take any one term constant and start multiplying. I'm going to deal with this term. So AB C bar D plus AB C bar, D bar. Then next term, go for the B bar. A, B bar, C bar, D plus A, B bar, C bar, D bar. Next A plus, sorry, A, B bar, C, D plus A, B bar, C bar, D. Next A bar, A bar, B bar, C, C, D plus A bar, B bar, C bar, D. Next A bar, B, C, D plus A bar, B bar, C, D plus A, B, C, D. Okay. So now you have to find out the common term, but actually this is a very big expression. So simply go for the putting it in the, or then later we can rearrange in terms. So this is like whichever is bar, the value is 0. The other one is contributing for the function. So A, B, D. A, B, D na 8 plus 4 plus 1, you will have 13. So 13, and this is 12, and this one is 8, and sorry, 8 and 9, and then you have 8, 9, 10, 11, 9 again. So this is an extra term. Same. So strike it out. Okay. Then CD is what? 3, then 1, then 7, then 3 again. This is an extra term. Strike it out. Then 15. So now rearrange it. Now rearrange it. So summation M 1, 3, 7, 8, 9, 11, 13, 12, 13, 11 I have given. 11, 12, 13 and 15. So all the terms are there. 13, 15, 3, 7, I think. All the terms are there. So this is the standard form of SOP. From this you can bring down the POS. What is that? Whatever is missing. 0 is missing. 1, 2 is missing. 3 is there contributed by SOP. 4, whichever 0, 1, 2 is missing. 3 is there. 4 is missing. Then 5 is not there, I think. So 5. Then 6 is missing. 7, 8, 9 is there. 10 is missing. 11, 12, 13 and then 14 is missing. So these will contribute for your POS. Okay. So this is the standard or standard form of your POS. So for this you can write the expression. How will you write the expression? A plus B plus C plus D. Okay. And into POS now, this is how it will look like. A plus B plus C plus D. So whichever is contributing will get a complement. A plus B plus C plus D is 4. A plus plus C plus D is what? Next to 5. 5 is what? 4 plus 1. Likewise, you have to write for so 6 now. 10 is what? 8 plus, then 14, so 8 plus 2, 8 plus 4, 12, 13, 15. Okay, so this is the standard form of POS. So next problem is this. So similarly, you have to simplify and you have to also you have to implement using NAND gates. So if you simplify this expression, so kindly I want you to try. You will get the answer. Already I tried this. So you will get the answer to be like, just a moment. So, so if you simplify and bring it to the standard canonical, because they are asking you to simplify the following Boolean expression using 4 variable KMap. This is a K is missing here. This is KMap and implement using NAND gates. KMap now. So how many other variables you have? Here only 3 variables. 3 variable now. Then you have to go for look at whether it is three variable x, y, z, 3, w. So 4 variables, sorry, 4 variables. So you have to see to it all the minterms should have all the 4 variables. So multiply with whichever missing in the form of a plus a bar. Then you cross multiply, then you will have the expression to be expanded, and finally you will have a standard form of SOP, which I'm going to write it in the form of min terms alone straight away, because I won't have time and space over here. So kindly you try solving it. I hope you may get it like this. If I have gone wrong, now kindly correct me anyway. You kindly try this problem. So this is how your 13 marks part B, part C questions would be asked in your examination. Like a little bit tough, like a simplification, that is bringing it to a standard form, that is one part, and then applying KMap, and then third part is implementing using NAND gates. So here this is the after simplification. This is step 1 is over, but you have to do it. Bring it to normal canonical SOP form. Okay. Next, plot the KMap. If you plot the KMap, this is a very interesting KMap where you will find grouping to be slightly tough. You kindly make use of your pencil skills in your exams so that it would appear neatly. Okay. So now the variables are nothing but again w, x, y, z, 0, 0, 0, 1, 1, 1, 1, 0. Okay, cell values, since I am kept on doing that, we know it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So here plot the value. 15, no, actually speaking, you have to rearrange this. So while plotting it, you will have it to be like this. Since it is a min term, it will be like this. Okay. If I'm not wrong. So after plotting it in the respective cell value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, this is 12, 13, 15, and this is 15. Okay, so now coming for your grouping part. Actually speaking, you have to do it step by step in your example. Okay, since I don't have space here, I'm going for it straight in one step. So next comes grouping. So first I have identified the structure. Second, I have plotted the values. Third, I'm going for a grouping. Grouping, I told you two things: observation and hierarchy. Hierarchy, 8 cells are together. If one is here, then 8 cell is possible. If that is missing, then 8 octet is not possible. Then what is the next grouping could be possible? You can group it in quads. Quad now 4 cells. So immediately most of you would look for this, because all 4 cells are adjacent. 3 is adjacent to 7, 7 is adjacent to 15, 15 is adjacent to 11. Okay, so in a way all the 4 are adjacent to one another. So this is group 1. Immediately when we see, we will name it. So next, who and all left out? These two are left out. These two, could you group it as a 3? No. Only pair. Anybody is adjacent to this? No. This is not adjacent? No. Whomever is adjacent, they don't carry any value. 0 wala don't carry. So I will go for a pair. What is the next grouping level? Next, if 4 is not found now, then I have to go for 2 cell combination. I have done that and I have named it as group 2. Next, who and all left out? This 1 is left out. For this, I have to first aim for, actually octet is not possible, so quad. Any 4 cells could I combine with this? If only if they are adjacent, I could. So 10 is adjacent to 11. Yes, I could club. 10 and 11 are adjacent to 2 and 3. So according to folding method, I can group and form this as group 3. Okay. Now, so in a way I am borrowing from this group. Next, this one min term is left out. For that reason, I'm going for again a quad. That quad could be like this, combining 3, 2, 7, 6. That is also right. Actually, that is only possible. Okay. So 3, 2, 7, 6. So this is one quad G4. Okay. So now you might be having a question. Like it looks like all the cells are being clubbed with all other groups. Yes, 3 is clubbed with this, 7 is clubbed with G4 and 11 is clubbed with the G1. But since 15 is left out free, for that reason I can retain G1. It is a valid group. It is not a redundant. So this is a valid group. If this is also clubbed with this as a pair, if this is not there now, then you can remove G1 again. Though it has been formed first, you can erase it because if you should plot the grouping only with the pencils. If you want to erase the grouping, you can. Even if you name it, you should not consider it as a group. And also you can put it, if you have suppose done it now, you can mark it as a redundant. Okay. Whereas in this problem, it is not like that. It is a necessary group. It is a necessary one. So we can't mark it as a redundant. Wherein suppose if all the cells are marked by all the groups now, then you can remove that group G1. Okay. So now I have grouped it. Now what is the function, simplified function? I'll write it here. F is equal to G1 is what? YZ. G1, G2 is what? A pair of WX with a common Y bar. Then G3 is what? A quad from top and bottom. So X bar, whichever the variable common, I'm taking it from the rows and columns. X bar. Then from these two columns, which is common now, Y. So Y. Then group 4, W bar, then Y. So here the W bar is common for this quad and Y is common. So this is a simplified expression. Draw the if you want to implement in NAND gates now, draw the AOI logic. What is the AOI logic? What is this? YZ. That is involving structure with and or not. That is what AOI. AOI logic circuit. Then WXY bar. WXY bar. Another AND gate. These are the min terms, product terms. Product terms could be obtained only by the AND gate. Okay. So how many of the product terms? Those many. But X na X bar and X. Then how will we get X bar? Like this. Inverter. Then Y. Okay. Then draw the AND gate. Next. Another AND gate. So already I have 4 minterms, yes, 4 minterms together. I am coming out with 4 product turns like using an AND gate, and together it is a SOP. SOP in a sum of. So I have to sum it now, which could be obtained with a logical OR operation. OR operation now, OR gate. Sorry. You draw it properly. I'm rushing it. Okay. So OR gate. So this is your OR gate. This is all these are your AND gate, basic logic gates. Now you will have this. This is the basic logic circuit which carries around 2 marks. Okay. And next you have to implement fully this circuit with your NAND alone. What is the condition? Step 1, draw the circuit. Step 2, replace AND by NAND. I'm doing it with some other different color with the same diagram. Replace AND by NAND. I'm doing it. Step 2, I'm doing it. Replace inverter by a NAND gate because I need NAND. Okay. So inverter by a NAND gate. I'm doing the step 2 for your kind information within the single slide. Okay. Here also a NAND. Here also a NAND. Okay. So it's already every literals are being and every stages of your circuit which was earlier in AOI logic, now it is getting turned into a fully NAND implementation. How? What is the condition? Step 2, you have to replace AND gate by a NAND gate straight away, and that is you are adding bubble at the front, at the output, and inverter just by a NAND. And then add a bubble to your OR gate at the input. How many of our input terminals are there? Add the bubble. So according to DeMorgan's theorem, you can apply DeMorgan's theorem. What is the first theorem? AB bar is equal to A bar plus B bar. What is A bar plus B bar? It means bubbled OR gate. So here this is like these are bubbled. So here according to DeMorgan, for an example, we have taken two variables A, B. Here you have 4 product terms. Got it? So bubbled OR gate. So simply speaking, you can replace a bubbled OR by a NAND gate. Okay? That means a NAND is equivalent to a bubbled OR. Did you get it? This is what they are trying to say. A bar plus B bar. So simply at the next stage, so step 3, the last stage of your, now you're going to perform your step 3, that is replacing your bubbled OR by NAND. Okay, actually step by step you have to do it. In the single PPT I'm doing it, but I'm telling you at which step I'm doing it. So what is the step 3? Bubbled OR is being replaced with a NAND, multiple input NANDs. So again I am going to have same stage. Why I have to do now? Look at this. Earlier you had AND or NOT involving all your basic gates. That means you have to pick up 3 different ICs which will consume your space, circuit board. Wherein I'm going to make use of, I've replaced it. How I did, I justified with you right now. But look at this, how many NAND gates we are replacing with right now, and this is the final structure. 1, 2, 3, 4, at the second stage 4, and the third stage is what? 1 NAND gate. Altogether, you know very well, in one NAND, 2 input NAND circuit, NAND IC, you have 3 NAND gates inside. IC 7400. 3 NAND gates. So here I could just make use of, and there are 3 input NAND gates with 4 gates in the. So kindly understand what we are trying to say now. For 4 gates, we can just simply replace with 1 IC. And similarly, we can club all these 3 with this one as one more. So all 8 gates will consume only 2 ICs instead of 3 ICs. So supply is less, supply is reduced, power, space has been reduced. So these are the reason why we go for purely a NAND or NOR implementation. So this is why the reason they call it as a universal gates. This is why they call it as a universal gates, NAND and NOR. Okay, this is the final answer for this question. Okay, hope you understood this. Hope you understood this. So after 4 steps only you will get this diagram. Step by step you have to do it for your full marks. So next problem we will see. So likewise you have to implement the same. Here simply they have given universal gates, but you try doing either NAND or NOR. The option is given to you. Okay, mostly people will go for NAND. Okay, this is with don't care. With don't care now, the circuit will be, the mapping will be like this. Here grouping is very important. That is why I'm doing it again and again. But I'm not going to repeat the implementation. Implementation is simple. So if you plot it, this is how you will get it. So how will you group it now? I think there is a lag in my video. Okay. Okay. So now you could see here these are the values 1, 3, 8, 13, 14 plotted in the minterms value 1 and 2, 4, 10 with the don't care. Okay. 2, sorry. 2, 4, 10 with a don't care. So I plotted it. Now grouping. Always with the don't care now give importance to the minterms. So here how many minterms are there? Only 0, 1, 2, 3, 4, 5, 5 is, no. So this is not there, sorry. So, okay. So now that is right. 13, 14. Okay. And this is 8. Okay. 1, 2, 3, 4, 5. So 5 minterms value and 3 don't cares. So if I try to group it now, octet is not there. 8 cell is not there. Next 4 cell together it's there. Adjacent to each other. No. 4 cells are not adjacent to each other in this grouping, because if here I have one or don't care, I would have grouped the corners if I fold according to folding method, the corners are adjacent to each other. So here this is missing, this cell is 0 cell is missing, so I can't go for quad. So what is next in hierarchy? Pair. While pairing, I have to give importance to what? The minterms. So minterms, these two are adjacent to each other. So I will group this as a group 1. Next minterm left out is what? Here I have a pair according to folding method. For grouping, I can make use of a don't care, but I need not give importance to a don't care. What is the don't care now? Don't care now. It could be either 0 or 1 with a symbol cross. This will carry a value of 0 when clubbed with SOP expressions or minterms. When we work with the problems POS now, it will be assumed as a 1 for SOP and 0 for POS. This is for POS, this is for SOP. So since we are dealing with minterms, then SOP. SOP now don't care, assuming it as a 1, we can group it. Okay. So now who Who and all left out? Now don't care, and min terms, but we should give importance to min terms. So again here, because of this, I can go for one more grouping like this. As I told you, we can borrow how many ever times you want from a group. This is group 3. Which is left out alone? This is. To this, none of the adjacent cells is filled with anything. So I'll go for single, no grouping. Okay. So single, we call it as a G4. So this is how you will get the expression of the 4. To be like W is equal to, single is what? G1 is what? W bar, X bar, then Z. G2, W, X bar, then Z bar. Then G3, W, then Y, Z bar. Then G4, interjunction of the rows and columns. W, X, then Y bar, Z. Y bar, Z. So this is the expression of the reduced expression of the given function with the don't care. Now implement using NAND gate or NOR gate. NAND gate, now then simply come out with the how many our product terms are there, those many AND gates. Then replace the AND with NAND, inverters with the simply with the NAND, and bubbled OR with your inverters. Okay, sorry, bubbled OR with your NAND. So finally again you will have 3 stages of NAND gates. So try implementing this with your NAND gates. I didn't do that, so kindly try it. Find out the canonical POS now. This is very simple. Whichever is missing, here X is missing, so Y plus Z. Here plus 0 doesn't make any change for this value, so X plus X bar, we go for that using that postulate into Y X, which is missing Z, so Z plus Z bar. Then again Y, according to distributive law, you can multiply like this and bring it down. Like this. And finally, what is the POS min terms? Actually, people will look this only for this value. So what is this X, Y, Z? It is a 3 variable function. So it is very well understood. You have to go for 3 variable values will be from. So if you have a complement, that value is contributing for POS. Here no complement, so 0. Here 1. Here also 0. So repeated. I'm not going to repeat it. Here also 1. How could that happen? X bar, Z, Z bar. Repeating. Oh, that is right. Okay, I made a mistake. Sorry, always you have to have it in one form. Like XYZ now, you have to write it as XYZ. X bar, Y plus. Alphabetic order it should be. You should not change it. So X plus. So now this is redundant extra. Repeating, no? So this is phi of m is 0. Now what is the value? 4, 2, 1. So this is 3. And this is what? 4, 2, 1. So 6. Sorry, 1. So whichever is carrying a complement, that is contributing for your value in POS. So what is the P simplified or the canonical form? 0, 1, 4 is the canonical form of POS. Did you get it? So this is how you have to do it. Kindly keep drawing. So these are the problems you can come out with. Again, if you simplify this, I hope you will get a value of, I'll give the answer alone. Please try doing it. Or if you people want to try it, you can try. While I search and give it for you. Oh, this is using KMap, right? KMap, using KMap, if you have to simplify now, first identify the four variables min terms. So this is in min terms. So as to plot it in KMap, you have to bring it out into a canonical form. Canonical form now, try inserting all the missing variables. If you do so, you will have the min terms to be contributed to be summation m of 0 to 5 7 sorry 0 to 5 7 6 8 10 and 15. So these terms, so this is the reduced. If you convert it into a canonical SOP form, you will get this expression, which I have written in a min term. Okay, so now if you plot it, again you have a KMap ending up like this. So how will you group it now? Look for octet. Octet is not there. 8 cells not together. So 4 cells. Yes, 4 corners are there. Group it. That is one group. Then which are left out now? So these three. So here this contributes for pair, and whomever left out. This is could be grouped with this or this. So I am grouping it with this. Why? Because no, I'm going to group this with this. So more number of pairs you will get in this mapping. Okay, A, B, C, D. You draw the structures properly. Since I'm running out of time, I'm doing it fast. Okay, so the reduced expression is B bar plus A bar B D B C D plus A bar in D bar. Okay, so try doing this. I have skipped so many steps. First, you have to convert it into SOP. After converting into SOP, the expression I've written it in min terms straight away. So that is one part of your answer carrying 4 marks, and then this is remaining 4 marks. Okay, so try this also. Next, reduce the following Boolean expression. Just you have to reduce the expression, which is a very simple expressions, but you have to remember all your postulates. That's what. So here, I'll just give the steps because this is very simple. A bar B D. You have to multiply it. Multiply it. Bring this A bar B inside. So you have to multiply A bar B D bar plus A bar B C bar D. Likewise, you will multiply. Bring it inside. Next, I'm going to simplify, rearrange. I'm going to take out the common terms out of those two. So A, B bar, B bar. I'm going to take out those terms common. Then simply I'm going to write the remaining. So C plus C bar is 1. So A bar, B bar, B bar plus A, B plus A bar, C, D bar. Since C plus C bar is equal to 1. 1. Then take out A bar B common, then write it as D bar plus A bar B common, then you will have B bar D left out, then plus AB. Okay, here no D bar now. Sorry. Then you will have A bar B into 1 plus AB. Then you will have the expression to be AB plus A bar B. Take out B common, A plus A bar, which is equal to B. Answer is B. Okay. So you can also try this. This is simple. You try doing this. You will get the answer as this is again 4 variable. Answer would be F. So take down this as a homework problems and try doing A bar, B, C bar plus B bar C. Again, this is a 4 variable with 1 quad and 2 pairs. And one don't care has to be left out alone. You need not group that. Okay. And I've just given the answer alone. Try doing it. 9's complement, 10's complement, I already did that. So in the same way, you have to do it. Take down all these things as a practice problems and try doing it. Okay. So thank you guys. Hope I have contributed something for your understanding, right? So we'll meet again. Thank you.